Ladies and gentlemen, the topic of today's talk is optimizing sinonasal irrigation using computational fluid dynamics. I'd like to thank the organisers for inviting me to speak today. A major project such as this requires the collaboration of several organisations, including Sydney's Westmead ENT, the University of Sydney, Melbourne's RMIT University, and funding from several sources, in particular the Garnet Pass and Rodney Williams Memorial Foundation. As one of the few research groups in the world specialising in this field, we also receive commercial funding. We are helping ResMed to design CPAP masks, ENT Technologies to design saline rinse bottles, and we have a patent pending with Optinose for our novel spray technology. Saline irrigation is widely used to clear the nose and sinuses and to distribute topical medications. So how do we optimise its use? Some of the important issues to address include the ideal head angle, nozzle angle and size, rinse volume, and squeeze force. We then need to account for the effect of anatomical and surgical variance. Unfortunately, the existing literature on saline irrigation consists of only a handful of small trials using subjective methods to estimate the force of irrigation. The limited evidence to date suggests that forward head position, extensive surgery, and squeeze bottle use gives the best irrigation results. By contrast, CFD provides accurate, quantifiable measures of critical factors at precise locations and specific times down to fractions of a millisecond. There have been a few published papers using CFD to assess sphenoid irrigation. A few years ago, our group developed a sophisticated new CFD model of saline irrigation using the volume of fluid technique. This creates a highly accurate computer representation of fluid and air passage through the sinonasal cavity. This is an example of a simulation of 70 mils of irrigation entering the left nostril and exiting through the right. This 2-second animation takes several weeks of continuous processing on a university supercomputer to create. From the same dataset, we can create detailed analysis of velocity and volume. Here we are seeing coronal slices, but we can also show images in sagittal, axial, and any other plane from the same data. We also developed a novel method of unwrapping the 3D mucosal surfaces of the sinonasal cavity onto a two-dimensional representation to show precise information in an unobstructed overall view. We subsequently used the same technique to assess the effect of head tilt on saline irrigation in a proof of concept for a single subject. We found that 45-degree backward tilt was the most effective, but can result in the patient covering themselves in saline, so may be best performed when in the shower. More recently, we used the same technique with various volumes and various squeeze forces in another proof of concept single patient model. We found that using 400 ml at the highest squeeze force gave the best coverage and wall shear stress. As a result of these experiments, we collaborated with ENT Technologies to create a 400 ml squeeze bottle prototype that is currently undergoing trials with patients. You can see a standard 240 ml bottle on the left, the 400 ml prototype in the middle, and the commercial version on the right. And I'd encourage any fellows that would be interested in trialling the larger volume bottle to please contact our group. At this stage, our publications have only involved a single patient CFD model. The next steps are to repeat the experiments with multiple patient models using multiple variables and to follow up the results with clinical trials. We'll also study the use of saline in anatomical and surgical variants. Our novel CFD model provides sophisticated and accurate data which has already identified that backward head tilt using larger volumes at higher pressure may be of benefit, with many more clinically relevant results to come. Most importantly, complex work of this nature requires a coordinated group approach, and I'd like to thank our team and collaborators, without whom this would not be possible. In particular, I would like to thank the Garnet Pass and Rodney Williams Memorial Foundation for their generous support. Thank you.